Open two browsers side by side. One is Brave, one is Chrome. They look almost identical. Same tab bar behavior, same address field, same developer tools under the hood, same rendering engine. The websites you open in both of them look the same, load the same way, and respond to the same keyboard shortcuts. Now look at what happened this month. Chrome disabled a class of browser extensions that powered some of the most effective ad blocking software in the world. Microsoft Edge announced it is following Chrome's lead, planning to complete the same transition by the end of 2026. The extension that many users considered the gold standard of online privacy protection, uBlock Origin, no longer works fully in Chrome's stable channel and is being phased out in Edge. Brave announced that uBlock Origin will continue to work in Brave, that Brave is hosting MV2 extensions on its own servers specifically to keep them available, and that even if every MV2 extension on the internet disappeared tomorrow, Brave's core blocking capabilities wouldn't be affected at all because they were never built on extensions to begin with. Two browsers, same foundation, completely different answers to the same question. That difference is the story. The foundation shared by Chrome, Edge, and Brave has a name, Chromium. It's an open source browser project maintained largely by Google that provides the rendering engine, the JavaScript runtime, the network stack, and most of the infrastructure modern browsers need to function. When Google releases Chrome, it builds on Chromium. When Microsoft released Edge in its current form, it replaced its previous engine with Chromium. And when Brave launched, it chose Chromium as its starting point too. This matters because it means Brave isn't some parallel universe browser engineering project that reinvented everything from scratch. It starts from the same code base that Chrome starts from. The same code that loads web pages, handles JavaScript, manages memory, and renders your favorite websites. What Brave does differently is what it puts on top of that foundation, or more accurately, what it removes from it and replaces. Brave's own documentation describes the browser as making significant changes to Chromium, removing features that harm privacy, modifying how the browser behaves on the network, changing how synchronization works, and building privacy protections into the browser itself, rather than leaving them as optional additions. The starting point is identical. The resulting browser is not. But before we get to the specific changes, there's something more basic to understand. What privacy protection used to look like for a browser user who cared about it. For most of the browser's modern history, the answer was extensions. You installed a browser, Chrome, Firefox, Opera, whatever, and if you wanted to block ads, you installed an extension that blocked ads. If you wanted to stop trackers from following you around the web, you installed an extension that blocked trackers. The browser was a platform. Privacy was something you bolted on top. This model worked because extensions could do something powerful. They could sit between the browser and the network, intercepting requests before they went out and blocking ones that matched a list of known trackers and ad servers. When you visit a news site that tried to load scripts from 40 different advertising networks, an extension like uBlock Origin could intercept those requests at the point of dispatch and stop them before they ever left your machine. The website got your request. The advertising networks didn't. This capability came from something called the Web Request API, specifically the blocking version of it. The extension told the browser, before you send this request, ask me whether to send it. If the extension said no, the request was blocked. It was simple, effective, and gave users genuine control over their browser's network behavior. uBlock Origin became the dominant expression of this capability. It was fast, comprehensive, actively maintained, and free. Millions of people installed it. For many of them, it was the reason they used Chrome at all. The rest of Chrome's ecosystem could be tolerated because uBlock Origin made the web navigable. Now ask what happens when the browser changes the rules that extensions can use. Google announced plans to change its extension platform years ago under a framework called Manifest v3. The name refers to the third version of a specification document that defines what browser extensions are allowed to do and how they're allowed to do it. The change that matters most for AD blocking involves the Web Request API. Under Manifest v2, the old framework, extensions could use the blocking version of Web Request to intercept and stop network requests dynamically. Under Manifest v3, that blocking capability is replaced by a different system called Declarative Net Request. Instead of an extension saying, ask me before you send each request, extensions under the new system submit a list of rules in advance, and the browser enforces those rules itself. Google and Microsoft described this change in terms of security and performance. The old model required a third-party extension to run code in the critical path of every network request, a potential performance bottleneck, and a security surface. If a malicious extension could hook into that blocking API, it had significant power over the browser's behavior. The new model keeps filtering logic inside the browser engine itself, reducing the attack surface and theoretically making extension behavior more predictable and auditable. These are legitimate arguments. The security concerns around powerful browser extensions are real. There have been documented cases of malicious extensions abusing broad permissions. The controversy comes from a different place. The new system limits how many filtering rules an extension can submit, doesn't support the same dynamic filtering capabilities that uBlock Origin's advanced features rely on, and shifts the locus of control from the extension to the browser. An extension under Manifest v3 can ask the browser to block certain things. An extension under Manifest v2 could block them directly. Chrome 138, released in July 2025, disabled Manifest v2 extensions across the stable channel. The August 31, 2026 deadline marks when remaining MV2 extensions are removed from the Chrome Web Store entirely, meaning they can no longer be installed, even if existing installs temporarily persist. Microsoft Edge announced this month that it is following the same timeline, targeting full consumer removal by end of 2026. uBlock Origin is one of the extensions caught in that transition, with no equivalent Manifest v3 version available at full capability. For millions of Chrome and Edge users, this is the end of something. For Brave users, the announcement barely registers. And the reason why is the most important part of this story. Here's what Brave said when the Edge announcement dropped. Their statement was direct: Manifest v3 will not weaken Brave Shields in any way. Brave Shields, their built-in ad and tracker blocking system, blocks ads and trackers by default, and it's built natively into the browser. No extensions required. Read that sentence again. Not an extension, not a bolt-on, not something you install from a store. Built into the browser itself, operating at a level below extensions, unaffected by changes to extension platform rules. This is the moment the title of this documentary makes sense. Chrome and Edge are asking, how should extensions be allowed to modify the browser? Brave, years ago, asked a different question. Why should privacy protection depend on extensions in the first place? An extension operates inside the browser's rules. Built-in browser behavior operates at a level the browser itself controls. When Brave blocks a tracker, it's not waiting for extension permission systems, sandboxing rules, or API limitations. The blocking is part of what the browser does. That architectural choice looks like a technical detail until the moment that Chrome changes its extension rules. Then it suddenly looks like the most important decision Brave ever made. But Brave's divergence from Chrome goes deeper than Shields. The changes to Chromium that Brave makes are distributed throughout the browser in ways that aren't visible in any single settings panel. Brave removes or disables Google-specific telemetry built into Chromium. Standard Chromium sends information back to Google about usage, about crashes, about the browser's environment. Brave strips those connections out. It modifies the network behavior of the browser to reduce the number of background connections it makes. It replaces Chromium's default synchronization infrastructure with its own client-side encrypted sync, meaning data synced across devices is encrypted before it ever leaves the device. It adds fingerprinting protections that randomize or block the browser characteristics that websites use to identify you even without cookies. Bounce tracking, the technique where a site redirects you through a tracking domain between your click and your destination, allowing the tracking domain to log your passage, is something Brave specifically defends against at the browser level. HTTPS upgrading, which routes you to the secure version of websites automatically, is built in. Cookie partitioning, which prevents the same cookie from being used to track you across different sites, is part of the default configuration. Each of these is a place where Brave made a different choice than Chromium's defaults, or where Brave replaced Chromium's standard behavior with something that serves users' privacy rather than the network's default openness. This is what playing a different game means in practice. Not different features, different decisions about what the browser optimizes for. The counter-argument to Brave's approach is worth taking seriously, because dismissing it would misrepresent what's actually happening. Chrome and Edge are not just browsers. They are platforms that thousands of enterprise organizations depend on for consistent, manageable, auditable behavior. Platforms that extension developers have built businesses and tools around for years. Platforms that must balance security not just against trackers, but against malicious extensions, credential-stealing software, and sophisticated attacks on enterprise networks. When Google argues that Manifest v3 improves security, that argument isn't manufactured. Extensions with broad permissions over network requests have been used in genuine attacks. Restricting what extensions can do, even powerful, legitimate extensions, reduces that attack surface. A browser that enforces its own filtering rules is less susceptible to extension hijacking than a browser where extensions control request blocking directly. Microsoft faces the same pressures with even more weight. Edge is deployed in enterprise environments where extension policies, group management, and consistent behavior are requirements, not preferences. The Manifest v3 transition has enterprise carve-outs specifically, because managed environments have different needs than individual users. So the question isn't whether Chrome and Edge made those decisions cynically or transparently. The question is what those decisions reveal about the different things those browsers are trying to be. Chrome is trying to be a secure, performant, broadly compatible platform for billions of users across diverse contexts, enterprise, consumer, developer, educational, while maintaining the ecosystem around Google's services. Every choice it makes has to work at that scale, across that diversity, while keeping Google's business intact. Brave is trying to be a browser where privacy protection is the primary architectural commitment. The user population Brave is optimizing for is someone who wants the web without the surveillance. That's a narrower brief and a cleaner one to execute. Zoom out one more level, and the strategic picture becomes clearer. The browser occupies a specific position in the relationship between a user and the internet. Everything passes through it. Every website visited, every search entered, every form filled, every file downloaded, every session on every service. For Google, the browser's position is strategically valuable because it provides context for Google's core advertising and personalization business. Chrome's deep integration with Google accounts, Google Search, and Google's broader ecosystem creates a reinforcing loop. The more you use Chrome signed into Google, the more context Google has for delivering targeted results and ads. For Microsoft, the same logic applies through a different set of integrations. Edge is the default pathway into Bing, Microsoft 365, Copilot, and Microsoft account features. The browser is where Microsoft's AI assistant surfaces. It's where Microsoft's cloud services are most easily accessible. It's where Microsoft's personalization features learn about what you do online. Neither of these facts makes Chrome or Edge spyware. Both companies provide privacy controls, publish documentation about data collection, and operate under regulatory frameworks that limit the worst behaviors. But the browser's role in their ecosystems means that decisions about what the browser does by default, what it shares with whom, and how much user control is available are not neutral engineering choices. They reflect the browser's position within larger commercial systems. Brave's commercial model is different. Its primary revenue comes from an opt-in advertising network. Users who choose to see privacy-respecting ads receive a share of the revenue in cryptocurrency tokens. The browser's interest is in users trusting it, not in the browser mediating access to advertising networks. That alignment is not perfect, and Brave's own services and ecosystem have attracted legitimate scrutiny over the years. But the basic orientation is different. Brave makes money when users trust it, not when advertisers can reach them. Bring this into 2026, and the stakes sharpen further. Browsers are not displaying passive web pages anymore. They are executing AI models, summarizing articles, understanding the content of what's on your screen, searching across tabs to answer questions, connecting to services that provide context-aware assistance. Edge has AI features that can read and analyze the content of any page you're visiting. Chrome increasingly surfaces AI-powered suggestions based on browsing behavior. This is genuinely useful. It is also a new category of access that the browser is gaining over the user's activity. When the browser understands what you're reading, what you're working on, and what you searched for, the question of who controls that understanding becomes materially more important than it was when the browser was just rendering HTML. Brave faces the same AI integration pressure as every other browser. It is not immune to the pull of features that require contextual access to what users do. But its architecture, built around local processing, minimal telemetry, and the assumption that user data belongs to the user, creates a different starting point for those decisions. The important thing isn't that Brave has solved the AI privacy problem. It's that as browsers gain more contextual intelligence, the baseline architecture they start from increasingly matters. A browser built around Google's data collection defaults and a browser built around minimizing data collection will make different trade-offs when they add AI features, even if those trade-offs aren't visible to a casual user. Now the title deserves its answer. What did Brave actually prove? Not that Chrome is broken. Chrome is extremely good at what it does. Not that Edge is dangerous. Edge serves hundreds of millions of users, including enterprise environments with serious security requirements. Not that Manifest v3 was created in bad faith. The security arguments for changing extension architecture have merit. What Brave proved is architectural. A browser built on Chromium does not have to behave like Chrome. The foundation is shared. The philosophy isn't. Every significant difference between Brave and Chrome, the default blocking, the removed telemetry, the modified network behavior, the built-in fingerprinting protections, the continued support for MV2 extensions through its own servers, is a place where Brave chose differently, using the same underlying foundation that Chrome uses. Brave's core privacy protection doesn't break when Chrome changes its extension rules because Brave never depended on those rules for its core protection. That independence, the decision to build privacy into the browser itself rather than into the extension layer above it, is what gives Brave the ability to say, truthfully, that Manifest v3 will not weaken Brave shields in any way. That statement is either impressive foresight or just the natural consequence of building the browser the way they built it. Probably both. There are genuine trade-offs. Brave's aggressive blocking can break websites that rely on certain scripts. Some features require adjusting shield settings for specific sites. Extension compatibility differences exist. Brave's own services and ecosystem have their own privacy considerations that deserve scrutiny. Privacy protection is about reducing exposure, not achieving perfect invisibility, and Brave makes that clear in its own documentation. But the core architectural bet, build the protection into the browser, not above it, has turned out to be more durable than a strategy that depended on extension platform permissions staying the same forever. Return to the two browsers sitting side by side. Same Chromium foundation, same rendering engine, same address bar behavior. Superficially, almost indistinguishable. Underneath, completely different ideas about what the browser is for. Chrome and Edge are optimizing a platform that must serve billions of users. Enterprise deployments, developer ecosystems, AI integrations, cloud services, and the commercial interests of the companies that built them. Those aren't small or cynical goals. They're just goals that make certain architectural choices feel natural, and other choices feel unnecessary. Brave is optimizing for a user who wants the web without the surveillance layer. That's a narrower goal, which is why Brave can make choices that Chrome and Edge can't or won't. Brave didn't need to build a new browser engine to make that point. It proved something more interesting. You can start with the same foundation and still build a completely different idea of what a browser should be. And as browsers become more powerful, more personalized, and more intelligent, as they gain access to more of what you read, what you think about, and what you're trying to accomplish, that difference may matter a lot more than which logo is sitting in your taskbar.